And welcome back to P6. This should be our final video. We're now going to talk about this last class of factoring method using factoring formulas. These are the three formulas we're going to be making use of. Difference of squares, a big one. We used it as a multiplication formula in the last section, but it's even more useful as a factoring formula. If you have one thing squared minus another thing squared, whether that thing is a variable and a number, or even a parentheses, you can break it up as a plus b times a minus b. And if you have a similar organization with cubes, you have a difference of cubes, subtraction of cubes, it will factor to this, a minus b times a squared plus ab plus b squared. You might think at the end, but this is a trinomial, shouldn't that factor? Well, you can try to factor it, but one of the results of using these cubic formulas are that the trinomial will always be prime, so you don't really have to worry about that. There's also a sum of cubes formula. It's very similar. I tended to remember these two formulas by knowing there's a binomial and a trinomial, and remembering the basic terms. The signs were what always gave me trouble. I did always remember the binomial in front always had the same sign as the sum or the difference. This one was the one that was hard to remember. The a squared and b squared are always positive, but the ab, it's the opposite of whatever sign it is. So the sum, it's a negative. The difference is a positive. You might ask, is there a sum of squares formula? Well, no. A sum of squares, like a squared plus b squared, is always prime. It will not factor. So you only have to factor it if it's a difference of squares. Occasionally you might see factoring formulas for perfect square trinomials. If you want to look at them, by all means look them up. It's just those types of polynomials we can already factor by other methods, and I don't really think the formula is any advantage over those. So let's do some exercises. Our first problem here is a difference of squares. If you'll notice here, 49 is the square of 7. So that's 7 squared. 4z squared, well, that is the square of 2z. You don't really have to write this step. I just put it in there so you can see what I'm using when I plug into the formulas. So I'm going to use the difference of squares formula. So this will be 7 plus 2z times 7 minus 2z. And we're done. These factoring problems are among the quickest if you recognize the form. If you don't, well, you may be there for a while. Sometimes they won't have the proper form until after you pull out some common factors. In our second problem we're looking at here, this is also a difference of squares, but here the first square is a parentheses. It's not really any different though. X plus 3 plus y times x plus 3 minus y. This problem, 8 is the cube of 2, so the first term is 2a to the third. So that's going to be our a in the formula. And then 1 is itself to any power. So if we plug into the formula for a difference of cubes, this will be 2a minus 1 times 2a squared don't forget to put the square around the entire thing. That's an error I've made before. The reason you want to make sure it's on the entire thing is because the square will square the 2. And for a difference of squares, this was positive. So 2a times 1 plus 1 squared. A final step is just to simplify that trinomial a single step. Because the 2a squared I can write as 4a squared after I distribute the exponent through. 2a times 1 is of course just 2a, and 1 squared is of course just 1. As we mentioned, that trinomial is going to be prime. It will not factor. 1 times 4 gets you 4, and 2 times 2 is the other possible factoring pair of 4, and neither of those add to be 2, so it is not factorable. This, you might guess, is a sum of cubes. 27 is indeed a perfect cube. It is 3x to the third power the binomial then would be a plus b, so 3x plus y then I'd have 3x squared plus, no, this is a sum of squares, so it's not going to be plus there, it is going to be minus there. Three x times y plus y to the third, y squared I should say. So that is 3x plus y times 9x squared minus 3xy plus y squared. Lastly, I just wanted to give some general guidelines when you're factoring. We might do another quick example at the end, but some general guidelines. The first thing you always want to do when you're factoring anything is look to see if you can pull out any common factors. I've said it once, I will say it again. Even if it's not completely necessary, it will make your work easier, and you've got to do it at some point. It's easiest if you do it at the beginning. After you've done that, you count the number of terms. If you have 2 terms, you should try one of those factoring formulas. Difference of squares, sum of cubes, difference of cubes. If you have 3 terms, try one of the trinomial methods, trial and error, AC method. If 4 terms, try grouping. If 5 or more, cry. We'll learn another method we can sometimes use to help us factor polynomials that are that large, but in general, we're out of luck. I will say, just as a final note, be careful when you're looking at a problem and it says factor completely, because often that will mean there are multiple steps to the factorization. For example, suppose I had this factoring by grouping problem. X cubed minus 4x squared minus 4x plus 16. I think this should work out. You pull out an x squared, you'll have x minus 4. Pull out a negative 4, and you would have x minus 4. Factor out the parentheses, you have x squared minus 4. And we're done, right? Well, wrong. The x minus 4 I can't factor any further, but the x squared minus 4, that's a difference of squares. So I need to take it one more step. X squared minus 4 will be x plus 2, x minus 2. This is very common, especially with difference of squares problems. Something along those same lines might be 1 minus y to the 8th. If they asked you to factor that, well, you do a single step. Y to the 8th, if you remember, is y to the 4th squared. So that will be 1 plus y to the 4th, 1 minus y to the 4th. And then the 1 plus y to the 4th won't factor any further because it's a sum of squares. But the 1 minus y to the 4th will, because it's 1 plus y squared times 1 minus y squared. And then neither of these additions. Oh, I put the 4th in the wrong place there. Should be there. Sorry about that. There you go. 1 plus y to the 4th. 1 plus y squared. One plus y and 1 minus y. And that would be the final factorization, because I can't factor any of those any further now. So I think that's where we'll leave it. Just be careful when you have a factor completely problem that you do take it down all the way. Just check at the end of a factoring problem, really, and make sure you can't take it any further. Alright, that should finish us off on this section. Next time, we should be dealing with P7, where we will be taking what we've learned in factoring and apply it to working with rational expressions. You will need to do a lot of factoring in rational expressions, so make sure to get in all the practice you can. I'll talk to you then.